Hello everyone. So in today's class, we are going to learn lens displacement method. Lens displacement method. Now let's see general case first. So here this is a principal axis and this is a lens. And let us suppose here it is a screen. And now let's keep object here. This is object. This one is lens. And this one is screen. Let us suppose the distance from this object to this screen is d. Distance is d, and this object distance from this lens is u. This is your u. Then this distance will become d minus u. This distance will become d minus u. Now u is object distance and d is distance between screen and object. Then using lens formula, here u is equal to u and phi is equal to d minus u. So therefore 1 by f is equal to 1 by v minus 1 by u. So this is minus u according to sign convention. So this is 1 by f is equal to 1 by d minus u, minus of minus. So this is becoming plus 1 by u. And if we will solve this, we are getting u square minus du plus df, which is equal to 0. And after solving this quadratic equation, you are getting u is equal to d plus or minus under root of d into d minus 4f divided by 2. This is the object distance for image is to be getting formed on the screen. This is a general case we can say. So when we are moving the lens ahead, you will get second position. And this is the first case where we are getting image form, and that is what the formula we have derived for u should be how much, so that we will get image formed on the screen. Right, this is the case number 1 we can say, or general case. Now next, now case 1. If d is less than 4f. This d is less than 4f. Then, so u will be imaginary, that is object distance is imaginary. So u will be imaginary, and no position of lens is possible. So physically, no position of lens is possible. Next one, case number 2. If this d is greater than or first equal to, I will take next possible case. If this d is equal to 4f. If this d is equal to 4f, then if you will substitute here in this formula, d is equal to 4f, this will become 0. So 0 into this d is 0, under root 0 is 0. So you will get u is equal to d by 2. So what we are getting? U will be equal to d by 2, and which is equal to 2f. And if you will get u is equal to 2f, then v is also equal to 2f, because in convex lens 2f means center of curvature, and if object is at center of curvature, image is also at center of curvature. So v is equal to 2f. Now, so therefore the minimum separation between the real object, therefore minimum separation between the real object and real image minimum separation between real object and real image is 4f. Okay, so it means whatever this d is their distance, if you want to get at least one image, the object and screen must be placed beyond 4 times of focal length. That is the meaning of this one. Okay, right? And next one, now let's see case 3, that is d is greater than 4f. Case 3, when d is greater than 4f, when d is greater than 4f, then you are getting two solutions for this. So first equation you are getting, that is first position of object u1 at d minus under root of d into d minus 4f and divided by 2. Second position of object, that is u2 is equal to d plus under root of d into d minus 4f by 2. These are the two positions of the object which are possible. Okay, so u1 and u2, d minus 4f by 2 and d plus d into d minus 4f by 2. These are the two positions of object possible. two positions of object are possible. Hence, we will get two real images. Okay, we will get two real images. And if you want to find v in these two cases, that is v1 and this, so if u is equal to u1, then v1 is equal to d minus u1, which is equal to this d plus under root of d into d minus 4f divided by 2, which is nothing but u2. So if object distance is at u1, then v1 is equal to u2, and if u is equal to u2, then v2 is equal to d minus u2, so which is equal to d minus under root of d into d minus 4f divided by 2, which is nothing but u1, right? So for that is for two positions of the lens, object and image distances are interchangeable. So that is for two positions of lens, object and image distances are interchangeable. Object and image distances are interchangeable. I will show you this figure. This is the principal axis, and you have placed object here at this point, and here is lens. This is the first position of lens, and then this is the second position of lens, and here is the screen at this point. Okay, so now this distance is u, and let us suppose this distance is x. This distance is again d minus u. Similarly, this distance is also d minus 5, because this is again u. Okay, this is what interchangeable. This is u, so this complete distance is d again, है ना? This complete distance is d. So if this is complete d and this is u, then this distance will become d minus u. Again, if this is u, then this distance will become again d minus u, which is interchangeable, you can see. And this one is what? This one is x. What is this distance? Is x between the two lenses. So from this you will get m1 is equal to 1 by m2, that is magnification, and therefore m1 into m2 is equal to 1, m1 is what? Height of first image because of first position divided by height of object into height of image of second position or due to second position of lens divided by h naught is equal to 1, and therefore h1 into h2 is equal to h naught square, and therefore h naught is equal to under root of h1 into h2, right? H naught is equal to under root h1 into h2, height of image of first position and height of image of second position. Next one, if you want to find focal length, in this only I am writing, this is all about this magnification and all. If I want to find focal length because of this, then this is equal to x divided by m1 minus m2. This is another formula which you have to keep it in mind for focal length. There is one more formula for focal length, so let's see that. And also this focal length formula I am writing here, f is equal to this small d square minus x square divided by 4d. Okay, d square minus x square by 4d. This is what focal length formula. So you have all the cases, possible cases, and the formulas which we have to use in this lens displacement method while problem solving. Okay, so let's move ahead now and let's see the topic, that is lenses with different media on either side. Okay, lenses with different media on either side. Lens with different media on either side. This is the principal axis, and let's keep lens here. Here is object, this is image. This ray is coming like this, getting refracted and entering here, getting formed image. So this is object O, this is image I because of this lens. Now let us suppose this is medium first, that is A. This side you are having refractive index mu B, that is medium 2, and this lens is having refractive index mu. Then, so let us suppose this surface is having radius of curvature, that is R1, and this side you are having, that is R2. So at surface 1, this is surface 1, okay, I am writing here 1, and this is surface 2. So see here the derivation. At surface 1 now, at surface 1, at surface 1, mu1 is equal to mu A. Yes, mu1 is equal to mu A. Next, mu2 is equal to mu. and R is equal to R1. So therefore mu by V1 minus mu A by U is equal to mu minus mu A divided by R1. This phi1 is not there in the diagram, yes or not? But phi1 is what? If we will see the refractive means refraction at curved surfaces, then I mentioned there phi1 is what and phi2 is what. Phi is what and phi1 is what. Phi1 is the image formed because of first surface that you have to understood, right? So call this equation number 1. And next one at surface 2, at surface 2, at surface 2 what we are getting, see, mu1 is equal to mu1 is equal to mu, next mu2 is equal to mu v, and r is equal to r2, and r is equal to r2. So if you will use again reflection at curved surface formula, what we are getting, mu b by phi minus mu by phi1 is equal to mu b minus mu divided by r. So if we will add this equation 1 and 2, adding equation 1 and 2, adding equation 1 and 2, what we are getting formula for this type of things, we are getting mu b by v minus mu a by u is equal to mu minus mu a divided by r1 plus mu b minus mu divided by r2, because this v1 and this plus v1 mu by v1 and mu by v1 will get cancelled if we will add, and this is what the final formula which we have to use in problem solving if you are having two different medias on either sides of the lens. Okay. Okay, so let's stop here. Bye for today.